Assalamualaikum warahmatullahi wabarakatuh. My name is Eli Shahira and today we're going to present about Resnet architecture. So what is Resnet? Resnet or Residual Network was introduced by Kai Ming Hee in 2015. It was designed to solve degradation problem where deeper neural network perform worse instead of better. Resnet uses residual learning and skip connections, which allow information to bypass certain layers. This helps the model to train deeper networks more effectively and achieve higher accuracy. Next, this slide shows the evolution of neural network. It started with the macular-Pitts neuron, followed by the perceptron for binary classification. Then the multi-layer perceptron solved more complex problems like XOR. After that, CNNs became widely used for image feature extraction. Finally, Resnet was introduced in 2015, making it possible to train very deep neural networks efficiently.
Now I will explain some real-world application of deep learning in computer vision. This application is image classification. It classifies an email into a specific category. For example, we input a picture of a cat, then the model predict a cat. And if it's a dog, and it will predict a dog. The second application is object detection. Besides identifying objects, it also shows where are they by drawing bounded boxes. Next, image localization. This is similar to image classification, but it only locates the main object of the image using one bounding box. Lastly, we have image segmentation. Instead of drawing box, it's label every pixel of the image. This gives a much more detailed understanding about the object and its shape. These applications are widely used in self-driving cars, medical image analysis, security system, and many other AI applications. Next is the Resnet architecture. First, the input image is pre-processed before entering the network. Then, the image passes through several convolutional layers where important features like edges, textures, and shape are extracted. After each convolution, patch normalization and reloop are applied to trans- make training more stable and efficient. The main feature of ResNet is residual block, which uses shortcut connections. These shortcuts help the network learn effectively, especially when the network becomes very deep. After all feature extraction, global average pooling reduces the feature maps into a smaller size. Finally, the full connected layer and softmax produce the final prediction by selecting the class with the highest probability. Now I will explain the key idea behind ResNet, which is residual learning. Instead of learning the full mapping directly, ResNet learns the residual, which is represented as fx. The output is calculated as y equals to fx plus x, where x is the input, fx is the learned residual, and y is the final output. The shortcut connections allow the input to skip a few layers and add it directly to the output. This gives several advantages. First, it will improve gradient flow and making training easier. Second, it helps the network learn faster and become more stable. Finally, it solves the degradation problem where deeper network normally perform worse. Because of residual learning, ResNet can be built with many layers while still achieving high accuracy.
Let's compare the multi-layer perceptron MLP with Resnet. MLP is one of the classical neural network models that we learned in the course. It consists of fully connected layers where every neuron is connected to all neurons in the next layer. In contrast, Resnet uses residual blocks which introduce skip connections. These skip connections allow information to bypass certain layers, making the network easier to train. Another difference is the feed-forward process. MLP only performs a standard feed-forward operation, whereas Resnet combines feed-forward with skip connection. to preserve important information throughout the network. When MLP becomes very deep, it often suffers from the vanishing gradient problem, making training difficult. However, Resnet can be trained with more than 100 layers because the skip connection improves gradient flow during backpropagation. Overall, Resnet is more effective than MLP for deep neural network because it provides better gradient flow, support deeper architecture, and achieve higher performance in image recognition tasks. This slide shows the activation function used in classical and modern neural networks. In classical neural networks, the threshold and the sigmoid activation functions were commonly used. The threshold function produces only binary outputs, while the sigmoid function produces values between 0 and 1. However, the sigmoid function has a major limitation. In deep neural network, it can cause the vanishing gradient problem, where the gradient becomes very small during backpropagation. As a result, the network learns more slowly and training becomes less effective. Modern architectures such as Resnet mainly use the ReLU or rectified linear unit as the activation function. ReLU is computationally faster and helps reduce the vanishing gradient problem, making it more suitable for training deep neural networks. Finally, the softmax function is used in the output layer. It converts the output values into probabilities, allowing the model to determine the most likely class for image classification.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amani Lisa. So today I will explain about the learning process of Resnet. Resnet is trained using supervised learning, which means the model learns from the label training image. So as shown in the flowcharts in the slide, the process begins by feeding an input image into the networks. So the image passes through the feed-forward process, where the network extracts features and produce a prediction. Next, the prediction is compared with the actual label using cross-entropy loss functions. So this loss will measure how far the prediction is from the correct answer. The error is then propagated backward through the network using back propagation. So during this step, the gradients are calculated, and the SGD, stochastic gradient descent optimizer, will update the network weights to reduce the loss. This training cycle will be repeated over many epochs until the model converge and achieve better prediction accuracy. So next, one of the biggest contributions of Resnet is its ability to overcome the limitations of classical deep neural networks. Traditional neural networks such as like MLP, multi-layer perceptrons, and CNNs often suffer from three major problems. So the first is the vanishing gradients problems, where gradients become too small during backpropagations, making the early layers difficult to train. So the second is the exploding gradient problems, where gradients become excessively large, causing unstable weak updates. So the third is the degradation problem, where adding more layers actually reduce training performance instead of improving it. So Resnet solved these challenges by introducing residual learning and shortcut connections, also known as skip connections. So instead of learning the complete mapping, Resnet learns only the residual function while allowing the input to bypass several layers through an identity shortcut. So this creates a direct path for gradient flow during backpropagations, reducing the vanishing gradient problem and making very deep networks much easier to optimize. So as a result, the Resnet can successfully train the network with more than 100 layers while achieving a higher accuracy and better training stability. So as a conclusion, Resnet is one of the most influential deep learning architecture because it successfully overcomes the optimization challenges of classical neural networks. So its main advantages include higher classification
accuracy, improve gradient flow, and the ability to train very deep networks efficiently through the residual learning. However, the ResNet also has several limitations. So due to its deep architecture, it requires high computational resources, larger memory, and longer training time compared to the simpler neural networks. So looking ahead, newer architectures such as like efficiency dense net, and vision transformer continue to improve deep learning by achieve a better efficiency and performance. So the ResNet remains as important milestone in the deep learning and has become the foundation for many modern computer vision models. That's all from me. So our group used Finally, I would like to demonstrate how our group used Notebook LM to support our research and the report writing. So firstly, we uploaded all the reference materials into Notebook LM, including the 3 research paper on ResNet, and then also our neural network lecture slide. So by doing this, the Notebook LM generated responses based on the uploaded sources. Okay. So firstly, we asked the Notebook LM to explain the historical evolution of neural network based on our sources. So it summarized how the neural network evolved from perceptron that can only solve linearly separable problems, then to the multi-layer perceptron that introduce hidden layers and backpropagation to solve more complex problem. Then explain how CNF improved. Then also lastly, it explain how the ResNet overcome the limitations by introducing the residual learning and skip connection. Then beside the answering the question, Notebook LM also generate the video overview which summarize the key ideas from all our uploaded reference. So we use this feature just only to quickly understand the architecture, skip connection before reading the research paper in detail.